Hello, this video is to talk about unit or lesson 10.3.3, inequalities with quadratic and absolute value. So earlier this year in chapter 9, we learned straight linear inequalities and how to graph them on a number line. So I'm just going to do a quick review here. So if I was going to solve the solutions to this, obviously it has infinite solutions. So when I backtrack this, I'm going to subtract 7. So now I have 2x is less than 5, and then divide by 2. So x is going to be less than 2.5. So again, that's going to identify my boundary point. So what you like to do is add a couple numbers on either side for the reader, just so they can kind of see the flow of all the solutions. So again, my boundary point, because there's no equal sign, it's going to be a hollow dot. And it's all numbers less than, so go this way. And again, you can easily plug in a number. So if I say I chose 2 from this side, 2 squared is 4 plus 7 is 11. And 11 is less than 12, so it makes sense that everything on that side is a solution. Now the difference is when we get into the absolute value family. So I'm going to do 10-132 as an example. So the equation is the absolute value of x minus 2 is greater than 3. Now, remember when we solve absolute value, a lot of times, because of the V-shape, you actually have two answers, kind of like quadratic has two answers usually, a lot of times. So what you would do is, remember when you have absolute value, you want to make this side equal to plus and minus 3. So I'm going to start with the first one. It's already a plus 3, so I'm going to leave everything the same. For this other side, I'm going to change this to negative 3. And remember, when you change this from a positive to a negative, you have to switch the direction of your inequality sign. So I'm just going to simply backtrack, and now I have x is greater than 5, and then when I backtrack this one, I'm going to have x is less than negative 1. So now what you're going to do is make your number line, and you want to make sure you give yourself enough room to, again, have a couple numbers on either side of your boundary points here. So in this case, I have a hollow dot on 5, and I have a hollow dot on negative 1. So now you have some choices to make. Is it going to be this area, or this area for my solution region? And what you could do is you could try a number like over here at negative 3. So if I put in negative 3 over here, negative 3 is clearly not greater than 5. So if it's greater than 5, probably over here would be a better solution. And this one is x is less than negative 1, so it has to be numbers less than negative 1. So nothing in between the two dots is going to work, and I can prove it to you. Let's say we take the number 2. If I put in 2, 2 minus 2 is 0, the absolute value of 0 is 0, and 0 is not greater than 3. So none of these numbers in here are going to work. If I put in negative 3 minus 2 is negative 5, absolute value is 5, and 5 is greater than 3. If I put in 7 minus 2 is 5, absolute value of 5 is 5, and 5 is greater than 3. So that's why it kind of looks like this. The next example I'm going to do is a quadratic example, and this doesn't have it. I'm not doing a book question. This is just one I made up. So this would be x squared minus 2x minus 24 is greater than or equal to 0. So one way you could do this is you could actually factor this into x minus 6 and x plus 4. So when I'm solving this, if I just solve this without the inequality for a second and I get the answer to this, that would be 6 and negative 4. So those would be my boundary points. I'm just going to count by 2's for time's sake here. So now I would have a boundary point that's a solid dot on negative 4. I'd have another one at positive 6. Now again, I'm trying to find out which way I should go. So I'm going to plug in 0 right now, just because it's easy to plug in for x and makes all my x's go away. So is negative 24 greater than 0? The answer is no. So if that doesn't work, nothing in between here works. So I'm going to try 10. 10 squared is 100. 2 times 10 is 20. 100 minus 20 is 80. Minus 24 is definitely still bigger than 0. So that's why this would work on this side. Now if I try negative 6 squared is 36. Negative 6 times negative 2 is 12. 36 and 12 is 48. Minus 24 is 24, which is definitely bigger than 0. Okay, so it would go this way. So again, the difference between linear and absolute value and quadratic is you're going to have more than one boundary point. And again, some possibilities are, like these two examples are both arrows going the other way. There'll be times where you might have to connect the two dots in the middle versus going on each side.